Hey, what's up guys? Welcome back to my channel. Welcome back to another video. If you're stopping by my channel for the first time, please consider subscribing to my channel. And while you at it, smash that like button for me. I really would appreciate it. In today's video, I'm going to discuss with you guys the topic of dynamic ARP inspection. It's a layer 2 security feature that we can enable on the switches in our network if we want to add some security to our network. It's a layer 2 security feature that you want to know if you are studying for the CCNA exam, which is the 200-301 exam, because it is part of the CCNA blueprint. So if you're studying for your CCNA and you're looking to take the exam real soon, I highly encourage you to become comfortable with the topic of dynamic ARP inspection. So the goal of this video is to touch on these 4 points. What is dynamic ARP inspection? What is dynamic ARP inspection looking to protect against? Because if you can understand what we're trying to prevent, you will understand why we would want to implement this feature. How does dynamic ARP inspection work? So once you enable this feature on the switch, what's actually going on behind the scenes to make this feature work? And then last, how do you actually get it configured? So if you want to enable this feature across your switches, how do you go about doing it? So let's look at the very first bullet point. What is dynamic ARP inspection? So as I mentioned earlier, it's a layer 2 security feature. And what it does is it enables the switch that's configured with this feature to inspect, meaning to look at closely, every ARP message that attempts to enter that switch, and only allow ARP messages to enter if the IP address to MAC address binding in the ARP message is incorrect. Now, in order to understand this, you need to understand ARP and how ARP works. And I'm going to assume that everybody watching this video is comfortable with ARP and understand how ARP works, ARP being address resolution protocol. So let's scroll down and let's look at this diagram right here, and let's kind of dive into what dynamic ARP inspection is. So let's just say that this computer right here, this laptop, he starts sending in ARP messages, and inside of the ARP message he says that I am 10.10.10.12 and my MAC address is B. He's going to generate this ARP message and he's going to attempt to send it to the switch, and it's going to arrive on this port. Before the switch can actually forward this ARP message, he's going to verify that the MAC address to IP address binding inside of the ARP message is correct, which in this case it is. Okay, his MAC address is B and this is the IP address that he has. Once the switch validates this, he will then forward this ARP message to wherever it needs to go. Now, if he happens to generate an ARP message saying that I am 10.10.10.1 and my MAC address is B, well, now we know that he's lying about what his IP address is, because his IP address is not 10.10.10.1. That's the IP address that belongs to the router. But he's going to generate this ARP message and attempt to send it to the switch, and it's going to arrive on the same port. The switch is going to inspect the content of this ARP message as well. And once he determines that MAC address B does not belong to 10.10.10.1 and that this is an incorrect IP to MAC address binding, the switch is going to drop the ARP message, meaning it's not going to be allowed to come in and is not going to get forwarded wherever it's trying to go. Because from a security standpoint, we don't want to forward an ARP message that contains incorrect IP address to MAC address bindings. So in a nutshell, that's what dynamic ARP inspection is. So let's look at the second bullet point. Why would you even want to enable dynamic ARP inspection to begin with? What exactly are we looking to protect against? when we enable this feature. So dynamic ARP inspection can prevent what's known as ARP poisoning caused by ARP spoofing attacks. ARP spoofing is when you spoof or when you lie about the IP address in an ARP reply message. And ARP poisoning is when your ARP table is populated with incorrect IP address to MAC address bindings. Now, ARP poisoning can lead to two types of attacks: denial of service attacks and man-in-the-middle attacks. A denial of service attack is an attack that makes a device or a service inaccessible to other devices. And I'll show you what that looks like in a second. And a man-in-the-middle attack is when an attacker positions their device, like a laptop, in the middle of two devices, so two other computers, who believe they are connected over the same physical link. So they're thinking they're connected to one another. They think they're talking to each other, and they're completely unaware that there's another device, the attacker, that's in the middle of their communication. So it's a man-in-the-middle attack. So let's scroll down and let's look at our topology again. So let's first look at ARP spoofing. Okay, this is when this laptop right here, because he's our attacker, okay, he's going to generate ARP messages pretending to be the router. So ARP spoofing really comes from IP spoofing. IP spoofing is when you modify or you lie about your IP address. You typically do that for one of two reasons. Maybe you're trying to hide the true IP address that you have. But there's other ways of doing that. You can use network address translation. You can use a proxy. When someone does IP spoofing, what they're really trying to do is impersonate somebody else. So for example, if I create an ARP message saying that I am 10.10.10.1, I'm basically trying to make it seem like this ARP message is coming from the router, because the router is the one that owns this IP address. So I'm trying to impersonate the router right now. And then I'm going to say that my MAC address is B. So instead of putting my actual IP address, which is 10.10.10.12, I put the router's IP address because I'm trying to make it seem like this ARP message is coming from the router. So right now I'm pretending to be the router. Now, if you were to send this ARP message into the network, and again, what I just went over, that's ARP spoofing. Let's just say that DAI, dynamic ARP inspection, is not turned on. What's going to end up happening is it's going to arrive here at the switch, and the switch is going to forward it to this PC. Now, let's talk about what happens when it gets to the PC. This PC is already maintaining an ARP table where he has a list of every IP address on the LAN and the MAC address associated with it. So he already knows that 10.10.10.1 is associated with MAC address C, because that's the IP address of the router. This is the MAC address of the router. He got this information via ARP, Address Resolution Protocol. Now, when he gets this bogus ARP message down here, where someone with the MAC address B is claiming to be 10.10.10.1, what do you think that causes him to do? Well, he's going to think that 10.10.10.1 no longer exists at MAC address C. So he deletes that entry. And then he's going to put a new entry, 10, and my pen's trying to act slow on me, so if it shows up kind of weird, do forgive me. 10.10.1 is now at MAC address B. This is what ARP poisoning looks like, because now you have an incorrect IP address to MAC address binding. The IP address of your gateway, which is the router, is no longer mapped to the MAC address of the router, is now mapped to the MAC address of the attacker. So what's going to end up happening is when you start sending traffic to your gateway, instead of it going to the router, it goes to the attacker. It no longer goes to the router because your ARP table is now poisoned. The IP address of your gateway points to the MAC address of the attacker. So that's where the traffic is going to go. So that's going to be ARP poisoning. Now, since your ARP table is now poisoned and all of your traffic that you thought was going to the gateway, which is the router, is now going to the attacker, there are two types of attacks that he can pull off. The first one is a denial of service. So if you are this computer right here and you are attempting to go to the internet, you have to be able to communicate with your gateway, who is the router, right? You got to be able to send your traffic to the router so then he can forward it off to the internet. Okay, that's how the traffic has to flow. But if the traffic is going to the attacker, and let's just say instead of sending it to the router, he drops it. So it's no longer going to the router, it's going to the attacker, and he's just dropping the traffic. What do you think that does from the computer's perspective? It means that he cannot get out to the internet because he can no longer reach his gateway. That's a denial of service. Your router is no longer accessible. So the attacker just pulled off a man or a denial of service attack, right? He's preventing you from being able to communicate with your gateway. And now you can't get out to the internet. So what about a man in the middle attack? So you still have the traffic going to the attacker, except this time he's going to forward the traffic over to the router. So in the end, the computer can still communicate to the internet. It's just that now traffic was supposed to be just between the computer and the router. Now it's going through the attacker. So if everything was perfectly normal, no ARP poisoning or anything, this computer is going to send traffic to his default gateway. And he knows that the default gateway has a MAC address of C. So when he sends it to the switch should know to forward it to the router and only to the router based on how switches operate. And it completely bypasses the attacker down here. But once you poison the ARP table and the gateway no longer is mapped to MAC address C, but now is mapped to MAC address B, when you send that traffic, it goes to the switch, but now it's going to the attacker because your IP address to MAC address binding is incorrect. But at the end of the day, he thinks he's sending it to the router, but it's going to the attacker. The attacker is still going to send it to the router, so then it gets off to the internet. But the whole point here is that it's only supposed to go from the PC to the router. It never should go to the attacker's laptop. So now the attacker has basically become the man in the middle. He's in the middle of the communication between the computer and the router. All the traffic is going to him. He can analyze it. He can listen in on it because he's getting all the traffic. He becomes the man in the middle. Like imagine if this were me, right? This is me right here. And I'm trying to talk to you. Okay? I'm trying to talk to you. Imagine the attacker is right here. So when I send this letter or this message, I think it's going to you, but it's actually going to him. And then he just relays it over to you. So we're having this conversation back and forth, thinking we're talking directly to each other. We have no idea that this guy is right here in the middle, getting all of that, and all he's doing is just passing it between us, and we have no idea. Okay, so that is what a man in the middle attack is. This is what we're trying to prevent with dynamic ARP inspection. See, if we were able to detect that the IP address, the MAC address binding was incorrect, then the ARP table on this PC right here never gets poisoned. And if it never gets poisoned, traffic can never go to the attacker. It's always going to go to the router because your ARP table is always going to be correct. So the next bullet point, how does dynamic ARP inspection work? So dynamic ARP inspection is used in conjunction with DHCP snooping. That's another layer 2 security feature you want to know for the CCNA exam. What will happen is the switch will compare the IP address to MAC address binding in the ARP message to the IP address to MAC address binding in the DHCP snooping table. So let me explain what that means to you. We're going to use this diagram right here. So the first thing you have to do is you must turn on DHCP snooping. Okay, dynamic ARP inspection will not work if DHCP snooping is not working. When you turn on DHCP snooping on the switch, basically what the switch will do is start listening in to DHCP messages, going back and forth between DHCP clients and the server. Since he's listening into these messages, going back and forth between the clients and the server, he knows what MAC addresses are assigned what IP addresses. Like if this PC right here is a DHCP client, and let's just say this laptop is also a client, the switch is going to know that MAC address A was given an IP of 10.10.10.11, and that MAC address B was given an IP address of 10.10.10.12. The switch is going to know this because he's listening in. And what he's going to do is he's going to put this information into a table called the DHCP snooping table. So inside of this table, he's going to make an entry that 10.10.10.11 was assigned to MAC address A, and 10.10.10.12 was assigned to MAC address B. He knows this. So then what happens when this laptop right here, because this is where the attacker is, what if he generates an ARP message and he says, I am 10.10.10.1. Okay, again, this is IP spoofing. Okay, instead of using his IP, he's using the router's IP. He's basically pretending to be the router right now. And he says, my MAC is B. And now he's going to attempt to send it this direction. Now we have dynamic ARP inspection turned on. So when that ARP message arrives here at the port, the first thing the switch is going to do is he's going to inspect this ARP message, basically making sure MAC address B really does own 10.10.10.1. So he takes this information and he compares it to the DHCP snooping table. Well, in the DHCP snooping table, MAC address B was assigned 10.10.10.12. So that raises a red flag. Why is he saying that he is 10.10.10.1? That's not the IP address he was assigned. So he's trying to do something fishy here. So you know what I'm going to do? I'm going to just drop that. I'm not about to allow this ARP message to come in, send it to where it's supposed to go, and then all of the ARP tables on all of the devices get poisoned with this incorrect information. So when those ARP messages come in, he sees the IP address, the MAC address binding in the ARP message. He compares that to the binding that's in the DHCP snooping table. This is why you have to turn on DHCP snooping, because that table is going to be used by dynamic ARP inspection to validate the IP address to MAC address binding. This is going to happen with all ARP messages. Now, ports can either be trusted or untrusted. Okay, ARP messages received on a trusted port are not inspected, so you're not going to look at the IP address to MAC address binding. ARP messages received on an untrusted port are inspected. All ports by default are untrusted. So that means that if this port is untrusted, which it is by default, any ARP message that attempts to come into that port gets inspected. You take the IP address, the MAC address binding in the ARP message, you compare it against the binding in the DHCP snooping table. If for some reason this PC right here is not a DHCP client, what you need to do is you need to put a static entry into the DHCP snooping table, or you can put a static entry as far as dynamic ARP inspection goes. Like, the switch has to have something to compare it against, otherwise it just drops it. But this port is going to be untrusted, so any ARP message is going to get looked at. But what about the router? What about the server? These are devices that we can trust. If an ARP message is coming from the server, he's not doing no type of IP spoofing or ARP spoofing to cause some type of attack, and neither is the router. So do we need to waste resources having the switch inspect every ARP message coming from the server? Actually, absolutely not. Does he need to waste resources looking at every ARP message coming from the router? Absolutely not. So what you do is you go to these ports and you make them trusted. If these ports are trusted, any ARP message that enters those ports does not get inspected. So you only configure trusted ports that connect to devices that you can trust. You leave the other ports untrusted. And then finally, how to configure dynamic ARP inspection. So the first thing you're going to do is you're going to enable DHCP snooping, because dynamic ARP inspection cannot work without DHCP snooping. So you say IP DHCP snooping. You can do this on a VLAN by VLAN basis. All you have to do is specify the VLAN right here. If you don't specify a VLAN, DHCP snooping will be enabled on all VLANs. So if you want to do it on a VLAN by VLAN basis, be sure you specify the VLAN at the end. And then you're going to enable dynamic ARP inspection. So you're going to say IP ARP inspection. And just like with DHCP snooping, this can be done on a VLAN by VLAN basis. If you just type IP ARP inspection, it's enabled on all VLANs. But if you only want to do it on certain VLANs, you type IP ARP inspection and then you put the VLAN number. Otherwise, it's going to be enabled on all VLANs. And then thirdly, you go to the port that you want to configure as a trust port, and you configure it to be a trusted port. So here I went to interface fast Ethernet 0/0, and the command is IP ARP inspection trust. Remember, every port is untrusted by default. If you want to make the port trusted and ARP messages do not get inspected as they're coming in, then you have to make the port a trusted port. And that's how you do it. And ladies and gentlemen, that is going to conclude this video. I want to thank you guys for watching. I really hope this video was informative. Again, if you're stopping by the channel for the first time, please consider subscribing to my channel. Everybody go ahead and smash that like button one time for the YouTube algorithm, so that way this video can be shared across YouTube. Again, thank you guys for watching. I hope this video was informative, and I want to thank you guys for viewing.